Hello guys, welcome to Collegewali PADHAI. So in today's video, we'll start the episode 1 of computer programming language. So today's topic is evolution of programming languages and problem solving. So let's start with the topic. So basically, can anyone tell me what is a programming language? As we know that we need instructions from our elders to move ahead or from any of our inspiration. The computer needs instruction of computer programs, or in short, we can call them as codes to control them. The computer program is also called as an artificial language. This is the main keyword, artificial language, that is used to control the behavior of the computer. So they are defined through syntactic and semantic rules. They are used to facilitate communication for organizing the task and manipulating information. Yeah, these are all the main things you need to learn. Then moving on to the next part. So this is all about programming language. Instructions, artificial language, behavior of computer, syntactic and semantic rules, facilitation of information, organizing task and manipulating information. Then what are the types? There are around three types of programming languages. One is the machine language, assembly language, and high level language. Machine language. Let's learn about machine language. It is the native language. It uses 0 and 1 to represent data. These are binary numbers 0 and 1. And in ASCII value of A is 0, 1 lakh 1. And suppose you see any image around, it consists of millions, or you can say billions of binary data sets that determine each pixel. So these are the important things you need to learn, and you can also focus on this diagram for any kind of reference. Why is this fan not working? Yeah, so this was about machine learning. You need not go deep into this concept, this is just an overview. Then comes the assembly language. If you feel that the video is going fast, then you can pause and watch it slowly. As I have a lot to cover now, so I need to go a little fast. So assembly language is what? Assembly language is for symbolic instructions and executable codes, and it uses letter instead of the zeros and ones, that is the binary data. And how are these produced? These are produced by compiling source code with the help of high level programming language. And here assembly code is converted to machine code. Assembly code is converted to machine code with the help of assembler. So these three things just you need to learn in assembly language. And you can also take a screenshot, or video is available in YouTube. You can watch it anytime you want. Then comes high level language. It uses set of words and symbols which are similar to English. And the programs written in high level language are called as source programs. And here the programs which are written, they are converted into machine readable form with the help of compilers and interpreters. So we have learned about the three languages, that is machine level language, assembly level language, and high level language. So next, let's move on to evolution of programming. Nothing to learn much. There are around 500 programming languages having their different syntax, style, features, etc. What you can say. First one who wrote programming was Ada Lovelace, and initially the devices were made by Charles Babbage. These are all common information you must know. Then assembly language, you can say it as a low level language. It uses symbols for the machines to understand, and it also creates computer viruses. Yeah, assembly language is used for creating computer viruses. Example is flight simulator navigation system. Autocode, you don't need to learn much. You just need to know the fact that it was the first compiling program. It was the first compiling programming language, and under autocode, COBOL and Fortran comes. Fortran is what? It was the first numeric and scientific computer program, and it has also written programs for NASA. Algol is what? Algorithmic language. Algol is the initial phase of Java, C, and C++. It was used for implementing that nested function, and it has simple syntax than Fortran, and it was the first programming language to use code blocks. That is begin and end. This one, begin and end. First, you need to know the full form, that is algorithmic language, and initial phase of Java, C, C++. Then it was the first program for implementing nested function, and it has easier or simpler syntax than Fortran. Then it was the first program to use code blocks, that is begin and end. Then comes COBOL. Just you need to learn that common business oriented language, and basic is beginners all purpose symbolic instruction code, and it was written by Bill Gates, Paul Allen, Monte Davidoff, who formed the company Microsoft. C. Everyone knows about C. C is the most popular language. It is also called as the mother of all high level languages, and C is used for many tasks just like operating system, embedded systems. They also help the websites through common gateway interface, or it is also known as CGI. So then you can take a screenshot of some other programming languages. Here also you can take a screenshot of some other Kotlin, Swift, Go, C Sharp, Java, PHP, JavaScript. Then we need to go through the concept of problem solving through programming, which is the main part. So what we generally do in life, we face a lot of problems. Sometimes we get the solutions easily, and sometimes we need to think of a bit harder. So when a problem strikes in our life or in our head, then what we do? Suppose let's take the example of a maths problem in an examination hall. So we see the maths problem that we have not done in any of the school books or reference books we follow. And so what we do? We can't just directly write the answer. We have not by hearted the answer. So we see the problem, we think it, we analyze it, then we start writing the answer, and then the answer leads to the formation of the solution. So problem arises, thinking takes place along with analyzing, then it moves to the solution. Then when problem strikes, then before thinking is the analyzing phase or problem solving phase. Means you, when you think, you start to solve the problem in your mind itself. Then this leads to formation of a solution in algorithmic form. Algorithmic form means a summary kind of thing. Then it leads to implementation phase. That is, you start writing in the piece of paper, and that is just like the computer programs we see in the computer, which acts as a solution to the problem. Then what can we tell as problem solving? Problem solving is the purpose of basic and sequential steps to arrive at the a result or solution of the given problem. or you can follow the other definition which is provided on screen. Then there are two phases of programming. One is problem solving phase, and another is the implementation phase. Let's talk about problem solving phase. Problem solving phase, what we have to produce an algorithm, we have to refine the algorithm step by step, that is close to the computer program. Then pseudocodes are artificial and informal languages that help the programmers develop the algorithm. And then implementation, the computer program, we have to test it in some of the languages. Then you can take the screenshot. Combination of problem solving, creative thinking, then plus critical thinking leads to problem solving. This you can take a screenshot and analyze. Then what is creative thinking? It is the process of innovation that leads to explore and reframes the problems we faced and comes up with innovative responses with the help of the knowledge we have on the problem domain, that relies on the ability that relies on our ability, and it is generative, non-judgmental and expansive, and it is divergent. You can also take a screenshot. Yeah. So what is critical thinking? Critical thinking is quite analytical, judgmental, selective. It is convergent. So how can we define critical thinking? Critical thinking is the process of diversified range of intellectual skills and activities that are concerned for evaluating the information and assumptions. If you want, you can take a screenshot too. So these are some of the critical thinking strategies which you can follow. Yeah, you can take a screenshot. That is remembering, understanding, applying, analyzing, evaluating, creating. So let me tell you the simple steps of problem solving process. Suppose a problem arises, you need to analyze the problem, then you need to have critical thinking, then you need to have imagine of the no, I went wrong. Sorry, my mistake. Suppose a problem arises, then you think it critically about the problem, then you analyze the problem, then you uh, lead to creative thinking, then you lead to imagine about the solution. So you can divide it like this: problem, critical thinking, analyzing the problem, creating creative thinking, then problem solving or solution. Done. It's quite clear. Or I will write it over here. Let me write it over here. Can I write first is problem, or else I have to write it here. Problem. What's the problem? I think it's quite difficult to write over here. Oh shit. Okay, how to write it over here? First problem, then it leads to critical thinking, problem, then critical thinking, then analyzing the problem, then creative thinking, Then at last you imagine about the solution. This is all about that. Let me enlarge it a bit. 12 I can do it as 30. No. 14, 24. Yeah. Problem, critical thinking, analyzing the problem, creative thinking, then solution. You can take a screenshot also. So these are some of the real world example. If you have poverty, there are dark dwellings, you lead to unhealthiness, it is dangerous, lack of dignity, and you can't study, lack of security, can't clean, can't improve home. And this is the solution: candles, oil lamps, firelight, tear down slums, relocation, skylights, windows, mirrors. And this is how it is planned. You can take a screenshot and analyze it yourself. This is not the main concept, this is actually the overview. So that's why I'm moving it quite faster. Then 6 steps in, you can solve a problem, specifying the problem requirements, then what? Then analyzing the problem, then designing the algorithm to solve the problem, implementing the algorithm, test and verify the computer programs, then documentation. Specifying the problem means the problem to be solved is defined, input, output, execution, time, then embedded systems are specified. Then analyzing the problem, the programmer should understand the problem and problem requirements. Once input and output are identified, then the programmer must think of the input items that are necessary. If those items are not available, then additional information are determined. If the problem is complex, then it needs to be divided into sub problems. Then algorithm, we have to design the algorithm to find the problem. So from the beginning of this video, I am talking of the algorithm. So algorithms are basically the framework and foundation of the computer programs. Algorithms are step-by-step process of computer programs, and each cases of classes of algorithm have the unique style and design. So then comes implement the algorithm. You can test the code. Once you can test the code that whether the program reads the input files correctly or not. Then the programmer requires additional details to perform the first operation of the program. He will check and compare whether the result comes by matching it with other data. If it's not correct, he will debug the program and check and make sure that there are no logical errors. Then is test and verify the computer programs. Once program has been written, it needs to be tested, executed, and verified. If there are no syntactical errors, then the compilation of the program will take place successfully. Documentation is what? Documentation is just a brief description of each step of the program, and this cannot be done directly. If the program has no errors, then only it will lead to the process of documentation. So this was just an overview of the evolution of programming and problem solving strategies and phases. So in episode 2, we will start talking about how to create algorithms, and we will also take some basic steps, or we'll take some examples how can we create simple algorithms. So till then, thank you. Subscribe to the channel. If you like this video, go give it a thumbs up and share with your friends. Thank you.